Welcome to Einstein Mechanics once again, and today we are looking at resolution of forces in space. Resolution of forces in space. This means we are going to tackle the three-dimensional what? Axis in order to resolve forces. In our previous episode, we only talked about what? Two-dimensional what? Axis. And in space, we are going to talk about the three-dimensional coordinate. So it is convenient to resolve a force in space into three mutually perpendicular components parallel to the three-coordinate axis. When we are resolving forces in space, this means that the force now can be resolved into what? Three-coordinate axis. Take into account three what? Dimensional. It's quite new, right? Remember, we have the two-dimensional axis where we have the x and y. But here, we are having three-dimensional for space where we introduce another axis called the z, as we can see. So let's take this image for instance. This is the force. The red line represents a force F, a certain force F in space. Like when we take this figure forming what? A cube or a cuboid. And we are trying to have a force, a certain force F. We can see that this force not only lies in the x-axis or in the y, but there is a certain z-axis to that it makes with the force. In such instances, we are going to use resolution into space approach, and it's quite interesting and simple. So here we call our axis x, y, and z. Another name, we name them I. We call this as our j, and the z as our what? K. Take note of that. So IJK system when we are dealing with the space resolution. So how do we go by this? What we see is that this force F is quite simple, makes an angle theta x with the x-axis, and this same force makes an angle theta y with this y-axis, which is the j, and the same force now makes an angle with what? The z, which is theta z. If it was to be in the two-dimensional space, we could have resolved this using resolution by what? Component, because it has an angle with the x and an angle with what? The y. But here there's a z, which is the k introduced. So how do we resolve such forces? So any force F which is in space can be resolved on the x as this. So let's take note of these formulas. So if I want to resolve it on the x, this force on the x, it is going to be f of x. That means the force on the x-axis should be equal to the magnitude of f cos the angle it makes with the x-axis. So what angle does it make with the x-axis, which is theta x? And this same force, if I want to know its component on the y, I'm going to have f of y, which is going to give me the magnitude of y, or the magnitude of the force cos theta y. The same thing, if I want to resolve this force on the z, I'm going to have the force on the z as the magnitude of the force cos theta z. So it's quite simple, meaning anytime we have a force in space, we have to resolve it onto all the three what? Axes. And this is how the first formula that must come in mind, that a force in space resolved on the x-axis is the magnitude of that force cos theta x, the angle it makes with the x, and on the y, which is the magnitude of the force cos theta y, the same thing on the z as cos theta z. And another formula which can also come up as this, so we call all these formulas as equation 1. Another formula that comes up is, if we want to, what if we know the magnitude of the force on the x, on the y, and on the z? How do we get the magnitude? magnitude of the force F, of this force F, of a force in space, can be given as h square F of x square and the square of the other of y square and f of z square, equation 2. So the square of this force is equal to the square of the force resolved on the x, resolved on the y, and resolved on the z. And it's another formula that will help us to solve problems when we are dealing with resolution in space. So always take in mind the square of the magnitude, the original force, is equal to the square of the resolution on the x-axis, the square of the resolution on the y, and on the z. So from this formula, we can also make deduction for any missing figure or any missing force. Then again, we can also obtain another force from this formula. If we want to know the magnitude of the force F, so we can say that the magnitude of a force F, which is the vector force, can be now this F cos theta x. We can add the I because it is in the x-axis, plus the same F cos theta y, which is in the g, plus F cos theta z in the k. This is also another formula we can obtain. The vector force can be, we have f of x as f cos theta x this way, f of y as f cos. It's like we are obeying this formula, but in another way, ignoring the square roots. So we bring in the values, and this is also a third formula we can obtain when we come to resolution of forces in space. So since we have a common f here, can we make this the vector force as f into bracket cos theta xi. The I and j, they are just showing you the axis on which the angle is taken from. So the I is telling you that this theta is taken from the x axis, and we also have plus cos theta yj taken from the y, plus cos theta zk taken from. So we have it this way. And we can also replace all this cos theta x and cos theta y, cos theta z with anything called lambda. So we can say finally our vector force is equal to the magnitude of the force and lambda, where this lambda is equal to the cosine of what? Xi plus cosine of this yj plus cosine of theta zk. So there's another fourth formula, which is what? Interesting. So if we want to resolve forces, we have to understand. It's just simple. The understanding is that we can resolve this force into what? Three axes. Just as in the resolution of two axes, we resolve it on the x and on the y. This one, there's a z, so we resolve it on the x, on the y, and on the z. And we can go through these formulas to find any missing parameter depending on what the question is asking you. And then again, since there are angles it makes with the axis, bear in mind this formula also works anytime you add the cos theta x square plus the cos theta y square plus the cos theta z square, you are going to get 1. This is our fifth formula. So in case you are looking for a missing angle, you can use this formula. Cos square theta x, cos square theta y, cos square theta z. should sum up to what? 1. Should sum up to 1. And with this, you can be able to find any missing angle. And it's quite interesting. We will solve questions and we will see how questions will ask us to find missing parameters, maybe the force on the x-axis given the magnitude, and we can use these formulas to obtain it. They can ask us to also find the magnitude of the force where we are given the resolution on the axis, and we can also use this formula to obtain the magnitude. If we are to find an angle, we can also use this one, and it's quite interesting. And let us not also forget that here is the same as f of x. X is still in the I, y is in the j, and z is in the k. The ijk system, mostly you won't be given x, y, z. It will be I, j, k. And you have to know that we are representing our x with I and our y with j, and we are having our z to be k. With this, we will be able to solve match questions. Let's tackle a question and we will see how best we will use this to solve them. Example 1. A force of 500 Newton forms angles of 60 degrees, 45 degrees, and 120 degrees, respectively, with the x, y, and the z axis. Find f of x, f of y, and f of z. So this is what we are asked to find. We have the magnitude, so solution. We have a force, that's the magnitude of a force, F, is giving us 500 newtons. It makes an angle with the x 60. So can we say theta x is 60 degrees, and theta, pay attention, theta y is 45 degrees, theta z from the question 120 degrees. And we are to find the f of x, we are to find the f of y, and we are to find the f of z. It's quite simple. So this is maybe in this form. We have a certain force. This is a certain force, and we know that this is our x, which is what? Our I. This is, so I'm showing you how this force may be represented. This is our y, which is our what? J, and this is our z, k. So maybe we have a force like this which makes an angle of 60 with the x, it makes an angle of 45 with the y, and it makes an angle of 120 with the z. And this is the magnitude, which is 500 Newton. And we are asked to resolve this force onto the x and onto the y, and find the magnitude also onto the z. So how do we go by it? We know that anytime I have the magnitude and the angle given, a force on the x can be resolved at the magnitude cos theta x. So with this, I'm finding f of x. The magnitude is 500 cos, what is the angle it makes with the x? 60 degrees, cos 60 degrees. So my f of x will now give me 250 newtons. Simple. The same thing if I want to resolve it on the y. F resolved on the y is always the magnitude of the force cosine the theta it makes with that plane or that axis y, which is 500 cosine theta what? 45, and I'm having my f of y to be 353.5 Newton. The same thing if I want to find the angle it makes with the z, which is the magnitude cosine theta z. I'm getting f of z to be 500, the same magnitude, but the angles will change, 120. And my f of z is now giving me negative 250 Newton. So these are the magnitudes of what? Forces if they are resolved on the axis. Meaning if this 500 Newton force is resolved on the x-axis, it will be 250 Newtons. If it is resolved on the y, we are getting 353.5, and on the z, we are getting negative 250 Newtons. And that's simple. Let's move forward. Example 2. A force F has the component f of x 520, f of y as that, and f of z as that. Determine its magnitude f and the angles ux, y, and z it forms with the coordinate axis. That's quite interesting. So our solution, our parameters, we now have f of x given as what? 520. We have our f of y given. This is resolution of forces into what? Space, three-dimensional. So it's quite different from the resolution into what? Dimension, 60 Newton. So with this, we are to find the magnitude, the original F. And this US, UY, this is the angle. So we can say, which is the same as theta what? X. But here we are using UX and UY and UZ as our angles. But we remember that the magnitude of the force square is the same as resolution on the x square plus the resolution on the y square plus the resolution on the z square. Yes, so we can fix in these values and punch to find the magnitude f. All right, which is simple. So can we say f is the same as the square root of what is f of x? 520 square plus f of y, which is 5230 square. I'm running, yeah, because it's quite simple. 560 square. And our f now will be 5285.54 Newton. So this is the magnitude f. The magnitude f with this formula. Our second formula we had. So we can get our magnitude f. What about the angle theta x, theta y, or ux, uy, uz? We also remember that anytime we have our magnitude f is the same as f of x cos theta x. Do we know this? Yes. So now if you are to find angle, this is theta x. And we are replacing it with what? Ux. So basically, it's the same thing as f is equal to f of x cos theta cos ux. Yeah, cos ux. So let's find the angles. So can I say cos ux is now equal to the magnitude? Sorry. So we have our f of x is the same as f. Is the same as f cos theta x, f cos theta ux. Yes. So our cos ux will be the f of x on f. So I'm getting us to be cosine inverse of what is f of x? 520 on what is the magnitude f, which is 5285.5. And our ux, the angle this magnitude makes with the x-axis, which is our ux, is equal to 84.35 degrees. The same thing on the y will be cos uy equal to f of y. Pay attention to the correction I made here. It's always f of x is equal to the magnitude cos theta x. So on the magnitude, and I'm getting my ux or uy to be cosine inverse of what is f of y, which is 5230 on 5285.5. And our uy, which is the angle, now is 8.31 degrees. The same thing, our uz will now be cosine inverse of what's f of z, 560 on 5285.5. And I'm getting my uz to be 83.9, which is interesting. So with this question, we got our magnitude of f to be that, and our angles to be 84.35, and on the y, it makes an angle of 8.31, and on the z, it makes an angle of 83.9. So if I'm drawing it something like that, this is my axis, and this will be the force. This is the force, the magnitude F. And the angle between the X was 84.35. You can see that on the Y is too small, 8.31. And with the Z, it's also 83.9. And we are good to go. Any question, let us know in the comment section. Now the third example. A force acts at the origin or of a coordinate system in a direction defined by the angle. So our theta x is 75, theta z is 130. Knowing that the y component of the force is 300 positive, determine the angle theta y and the other component and the magnitude of the force. That's quite interesting. So solution. Let's get our parameters down. So I have theta x. Pay attention to this question. 75 degrees. I have my theta z, 130 degrees. I also have, knowing that the y component of the force, which is Fy, to be positive 300 newtons. Now determine, I have to determine theta y and the other component, which is f of x and f of y. I have f of y, f of z is unknown, and the entire magnitude f is also unknown. So we have about 4 unknowns here. How do we go by it? First, let's get the angle theta y. Do you remember this? Cos square theta x plus cos square theta y plus cos square theta z is equal to 1. Yes. So we can play with the values to get our cos theta y. Upon making cos theta y the subject, I'm going to get cos, let's say cos square theta y will now be 1 minus cos square, what is theta x? 75 minus cos theta z, cos square theta z, 130. So, I'm getting cos square theta, so I can find the square root of that, right? I'm getting cos square theta y to be 0.5198. And if I have to find cos theta y, not square, so I find the square root of both sides so that this square will cancel, giving me cos theta y now to be 0.721. Taking cos inverse, remember the cos square, you cannot take cos square inverse, so you have to make it cos theta y, and I will take cos inverse inverse of 0.721. I'm getting my theta y to be 43.86. So if you forget this formula, there's no way you're going to obtain your theta y. I have my theta y to be 43.86. How do I find my other component? The other component can be found. Remember, f of x can be found by f cos theta x. But here's the case: I don't know magnitude, the magnitude of the force F. But now I know the Fy. I also know the angle. So I can get Fy, F cos theta y. I can get my F from here. Are we good? Okay, so my F from here will be Fy, which is 300 on cos theta y. But cos theta y from here was 0.721. Therefore, my magnitude of the force F is 416.1 newtons. Interesting. So I now have my magnitude of the force F. I can find the other component from here. So my F of x will now be 416 cosine, what is theta x? 75. So F of x now will be 107.69. I can now find f of z as f cos theta z. These are the other components. So 416 cosine, what's theta z? 130. And my f of z is giving me negative 267 newtons. Interesting. So you see this example, we were to find one missing angle and the other component. So this is how you go through. Let's tackle this last example and see how we go. Determine the magnitude and direction of the force F. 650 Newton I, 320 Newton J, 760 Newton K. Do you remember the IJK system? Yes, that's the importance of the IJK. So my magnitude F is 650 Newton I minus 300 Newton, 20 Newton J plus 760 Newton K. So indirectly, my F, we know that this formula is the same as F of x I plus F of y J, and we have F of z what? K, this way. So can I see my F of x now is that, and my F of y now is that? Yes. So my F of x now is 650. My F of y is negative 320. My F of z from this, which is the magnitude of z, 760 newtons. Okay, so determine the magnitude of this F. We also know that magnitude of F is always the square root of f of x squared, f of y squared, and f of z squared. So my f now will be that. So f of x is 650 squared plus negative 320 squared plus 760 squared, and this magnitude is giving me 1050 newtons. So anytime you're given the question in the IJK system, always the I represents the force on the X, which is 650, and this J on the Y, which is negative 320, on the K is on the Z, 760. And I have now determined the magnitude. What about the direction, which is the same as the angle they mix with what? The respective axis. So I can find that I still know that, but f of x is always f cos theta x, which is cos theta x. Theta x is what I'm looking for. So can I say theta x now is cos inverse of f of x on f? Yes. So my theta x is cosine inverse of f of x, which is from the question, it says 50, the magnitude 1050, and my theta x is 51.75. The same thing will apply to the other ones. My theta y will be cosine inverse. What is f of y? Negative 320 on 1050. My theta y, the direction on the y, is 107.7. The same thing, my theta z will be cosine inverse f of z, which is 760 on 1050. And my theta z now is giving me 43.6 degrees, which is interesting. So you can see that these are examples and problems on resolution of forces in space. These are just the simple ones. In the next episode, I will do a video on the complex ones, those that involve diagram, and we will see how to also resolve them. Thank you for watching this episode.